Hi, good morning. It's Gene from the Magnetosphere Observatory. So, this video, like the title will probably say later on, is probably one of the most important videos that we've ever did here at the Magnetosphere Observatory. And that is because we are now in a position to make a few accurate predictions. I'm pretty sure that I'm 100% confident on knowing where the magnetic North Pole is at this moment moving and where it's going to reside for a long period of time, whether that is the position of where the magnetic pole is going to stay remains to be seen, because there's a lot of things taking place. But right now we are able to at least point to a position on the map and say that's where it's going, and we know that for this reason, which I'm going to get into in a minute. The other thing is with this video is I'm going to explain why the pole has started to migrate, which is one of the things that a lot of these mainstream organisations have not come out and told us, even if they know those reasons. There are a couple of implications I think that we're going to face, because now we know where the pole is going to be. We also know that the angle of our magnetosphere is going to change on this planet in the not too distant future, probably 2.5 to 7 years away, and I'll explain why. It could be any one of those numbers. But right now, as I pointed out in a video I did yesterday, there is something very strange going on with our magnetic North Pole, and I'll point that out a little bit more clearer in a demonstration which I'm going to do for you, so you can get a visual on what's taking place over our northern hemisphere. But I also want to say, we've spent a lot of time, and even though we've not had a massive budget, to answer these questions is not easy because of what is involved. It requires a lot of man hours, and as you know, it's just me here at the observatory, and it's usually me here that's building the equipment to monitor these things. So it's been a massive effort for just one person, and even despite all the odds and the funding that NASA get, we don't certainly get those large quantities. It should stand as a testament to what can be achieved on a low budget with just a couple of people. And I've got to say a big thank you to those people that have got our magnetometers in different locations now around the world, and now starting to receive muon detectors so that we can monitor the radiation on the surface of the Earth with regards to muons. And we know why we get those, because they're to do with interactions in the upper atmosphere with cosmic rays, which is on the increase because of a grand solar minimum and a weakening magnetosphere. But we do face, in my view, and I will talk about this as well in this video, I want to make this probably the most informative video to date that we've did here at the Magnetosphere Observatory, and I hopefully that you'll appreciate why that is. So just briefly, with regards to why our magnetosphere is going to change, I'm going to show you a diagram a bit later on, and I'm going to show you what's happening with our magnetic poles and why the magnetosphere is going to change its position. Now, the important thing about this is we do have two weak spots if you're looking at a two-dimensional diagram of our magnetosphere, and I'm talking about the cusp regions. And these are vulnerable regions. It's because even when we've got full strength magnetosphere, they do allow a certain amount of cosmic rays into our upper atmosphere. So even if we weren't in a solar minimum and we did have a full magnetic field strength, which we don't have, we would still receive inbound cosmic radiations through these two weak spots. Now, I'm going to show you where the magnetic North Pole is going to be, probably in around about 4 years' time on this planet. As a result of that, our magnetosphere is going to change angle with regards to the position of the Sun. And, we are still going to effort this, but we do see that it could align one of those cusps with directly the Sun, where we usually get full protection from the magnetosphere. It's going to align it up on the cusp, and we could get a lot more inbound radiation. Now, the changing of the angle of the magnetosphere could have been changing very slightly over the last 60 years. And that could be more so responsible for the noticeable change in the climate on the planet. and we know how cosmic rays interact with the upper atmosphere. They cause cloud seeding. I know it's a bit of a dark area because, you know, the European Space Agency have built the cloud chamber, and I'll explain why I think it was badly experimentally done. It's because they only chose to use a couple of the molecules which we have in the atmosphere, and perhaps if they'd have been a little bit more honest with their experiment, we would have found that, you know, when we interject cosmic rays into that cloud chamber, they would have formed cloud seeding particles. But there has been a lot of work by now more than one or two scientists that, you know, are confident in the fact that through more cosmic rays in the upper atmosphere we do get more cloud seeding, and that certainly would explain why, you know, we see the breaking down of the jet streams now as we do, both over the northern and southern hemispheres of our planet, because we do have an open gap at both ends, and that's because of the actual shape of the magnetosphere, which I'll get into in a little bit more detail. What I want to do right now is just show you why something very strange is going on over the northern hemisphere of the planet and why I've been focusing on that. So let me just show you in a quick diagram, or a little experiment that I've got set up over here. So we've got two neodymium magnets, one there, one there. We've just put there for reference Canada and Russia, because I'll tell you now, the pole is going to end up probably in 4 years' time somewhere in central Canada, and I'll show you the evidence that we have to date for that. So as you can see, the north red tip of the compass is pointing towards the Canada magnetic intensity. Now, as you guys have seen in many videos that I've done, we have two intensities, but because the one neodymium magnet is pushed right out of field, it is not having an effect on the compass. At the moment, we probably would be in a time scale 100 years ago, before the poles started to migrate. So I'm just going to show you what happens. From what we've seen, we know that the intensity over Canada has been weakening. So as a result of that, when the field in Canada weakens, and we know the field in Russia has been increasing, what we've noticed is that even though, when I show you on the NOAA magnetic intensity map later on, we do have two strong regions over the northern hemisphere, one over Canada, one over Russia. The one over Canada is weakening, and as a result of that, the compass needle, as you can see, when I move the magnet away, starts to drift somewhere in the middle. Now, we've seen the intensity from Canada leaking over for some reason into the Russian continent, and as a result of that, Russia's intensity has been increasing, and you can see what happens to the compass needle now as that happens. So as one weakens, the needle moves somewhere into the middle, and then as one increases strength, you can see there that the needle is virtually in between the two magnetic intensities. If I put the field viewer on there, you just see that these was intensities, but we've got obviously not just magnetic intensities, we've got the dipole, and the dipole, as we will show, if we look at the south pole on our planet, the dipole is directly in the centre of the intensity. But there's something different on our northern hemisphere. We've got two large intensities. One is weakening and one is getting stronger. And as a result of that, look what's going to happen first of all, we'll weaken the Canada one. So we've seen, say, the last 7 years, the Canadian intensity over that region get a lot weaker. As a result, you can see the compass needle wants to go further over towards Russia. That is exactly what we're seeing with the dipole, or the North Pole right now. It is going towards Siberia. And at the same time as seeing the Canadian high intensity or magnetic intensity weaken away, we've seen the Russian one increasing in strength. So what's going to happen is, as it continues to do that, it is going to be drawn more towards Russia. Now, there is an intense field over central Russia right now, but it doesn't have a dipole in the centre, like the southern hemisphere of our planet. So we can say that at some point in the near future, the magnetic North Pole is going to be somewhere centrally over the continent of Russia. Whether we get at that point, because there is something else going on here, guys, but whilst let's just deal with the situation at this point. So we're probably 4 years ahead now. The compass needle is pointing central in the centre of Russia. What's happened is, as a result of this, is our magnetosphere has also changed angle, and that will be a change with regards to the sun, and that could align one of the cusps, which I'm now going to show you just briefly before we have a look at the NOAA charts where they're saying the magnetic north poles are and the high intensities, and we can have a look at those field strengths as well. That is where they're saying we could, because of sorry, I lost the train of thought. Okay, so at this point, the needle hasn't reversed. There hasn't been a magnetic reversal, but there has been a change in the position of the magnetic north pole. Now, we know we've got a south pole as well coming up on the equator. And as a result of that, we could see these two attract each other. And as you can see, when that happens, we get a reversal. So that, up until, you know, the bit where the two come together is, you know, I would say 100% accurate. We also have a change in the future position of the angle of our magnetosphere with relationship to the sun, which could put us in a vulnerable position with regards to more inbound cosmic rays. It could also be the reason why, you know, the amount of cosmic rays that have entered the jet streams are where they are right now, and as a result, you know, it's attracted more water vapour and obviously changing the climate on our planet as a result of that. So let's have a look at some of the charts now on the computer, and we'll just recap what we've saw. I'll also show you some of the data that Swarm put together, which shows the intensity over Canada dropping off and the intensity over Russia increasing, and at the same time the dipole, or the needle on the compass, rushing over towards there. So yeah, you know, after a few years and a lot of perseverance, we're now you know, in a position to start saying what is the next steps that's going to happen, and you know, it is strongly looking like that is going to be the case. I mean, like I say, guys, I can't be any more confident than what I am. I am 100% confident that the you know, the pole which used to reside in Canada 100 years ago is going to be in Russia within the next decade, and centrally as well, and you'll see why that is the case. So on this chart, we're looking at the main field total intensity. Now, you can quickly look at Canada and Russia at the moment. See, there's not a lot of difference in between the two intensities in those regions. And it shouldn't come as a surprise where the magnetic North Pole right now is. If we just drew a line up over England, or where Ireland and England are, straight up vertically, just a little bit beyond 12 o'clock, if we was to use that as the way of gauging where it was, almost 1 o'clock over the UK, far north, that is where the magnetic North Pole, or the dipole, is. So it's not like down here in the southern hemisphere, where the South Pole is. If we see the main field intensity, where the intensity is at 65 nanoteslas, you can see that the dipole, or the South Pole, is directly in the centre at that intensity. Now, like we just had with the analogy of the two magnets, one in Canada, one in Russia, you could see the compass needle was pointing directly in between the two, and that was because they was equally weighted. But what's actually happening over Canada, and has been doing so for the last 100 years, is the field has been weakening, whilst at the same time the field over the central Russia has been increasing in strength. And at the same time, the magnetic North Pole left Canada and started to drift over the Arctic circle towards Russia, and at the moment lies about in between the two of those main fields, only slightly more to Russia now, as we've been tracking. Now this is this year's total intensity map, and on this map we can see where the two magnetic north poles are. The one magnetic north pole and the one magnetic south pole, but we can also see the two intensities over Canada and Russia, and we can also see down below, bottom right hand corner, where the south magnetic pole is. Again, I just want to point out that the magnetic safe pole is in the center of the high intensity. Now, it's a bit deceiving because what NOAA's done here is they've unfolded a global map out on a square piece of paper. So that's why if you look at the top right hand corner, that's where the magnetic north pole is. But I'm sure if we'd done the longitude and latitude, it would show us that the magnetic north pole is somewhere where I said, which is central north above the UK and Ireland. So what does this mean? Well, in the next video clip of an animation of the shrinking of Canadian intensity and the increasing of the Russian one, you will also see at the same time a magnetic north pole migrating towards Russia. And it's just logical sense that if we get more dissipation of that high intensity over Canada and an increase in Russia, we know exactly where the pole's heading, because if we look on the southern hemisphere of this planet, we know that there isn't a challenging pole like there is, or a challenging high intensity region like there is over the northern hemisphere. So we know where the magnetic north pole is going to eventually end up, and that is over Russia, in the center of that high intensity region, which continues as we speak right now, guys, to increase in intensity, whilst at the same time Canada decreases. Let's have a quick look at the animation so we get a better visual as to what's going on. So I'm running the animation. You can see in the top left corner of the animation we've got the two high intensities of the regions. If you look carefully, you will see them shrinking off, but you can see it a little bit more clearer on the bigger disc at the bottom central of the animation. What you see is Canada high intense region shrinking off, and it's done it, as you can see in the time scale that we're watching, within about 10 years or even less, and it's reduced almost in half its field intensity strength. At the same time, we are watching the dipole on that animation migrate towards Siberia or towards Russia. At the same time, you'll note that the magnetic north pole isn't at the moment in any of the high intensity regions, and that's because they are fighting over the dipole, and we can see who's going to win, because if we look over Canada, we can see that that high intense region is actually increasing in strength. Again, we know it's going to end up in central Russia, because if we just look at what's going on over the southern hemisphere, there is no challenging high intensity region to challenge the only one that's there. As a result, the dipole, or the safe pole, is directly in the center of the high intensity region. We also have watched over the years the safe pole high intense region creeping up towards the equatorial region, and as you can see, Russia is increasing towards the equatorial region, so they are merging together. And I believe when they do come together, like we saw in the analogy or the experiment I just showed you with the two magnets, when they converge, they will click together, and you saw the needle reverse into its reversed position. We could be less than a decade away from that actually happening, but at least we know now where the magnetic north pole is going and where it's going to end up, and why it's moving in the first place. It's because the Russian high intense region, or in high intensity, is challenging the high intense region of Canada and is winning the dipole. As a result, the poles are moving. But there's more to this, guys, and I'm just going to show you this one last thing, because I think it's important, because it gives you an idea of why we could be experiencing such calamities with our climate right now on the planet. And that's got to do with when our magnetosphere is affected by a pole reversal, as we're experiencing, we have changes in the actual shape and position of our magnetosphere with relationship to the protection that we get from the magnetosphere, from cosmic rays alone just coming from the sun, let alone from what's coming outside the heliosphere, which has been weakened by the grand solar minimum. But we are getting a lot of cosmic radiation off the sun as well, and we have two vulnerable spots. And I just want to quickly show you that if our magnetosphere changes its angle to the relationship to the sun, we could receive a lot more cosmic radiation as a result of that, it could be the reason why we've seen over the last 30 years dramatic changes to our climate, because the small change to the angle of the magnetosphere has already allowed a lot more cosmic radiation in through specific regions on the magnetosphere. And for me to get you to understand what that is, I need to bring up the diagram for the magnetosphere so you can see its components. So let's do that. So you can see the different components that make up our Earth's protective shield. This is what we call in general just the magnetosphere, but the important points here is you can see where the solar radiation, or solar wind in this case, hits the bow shock of the magnetosphere. You can also see that we have these two vulnerable areas here, which is the cusp. Now we know the Earth's rotation, we know the angle of the rotation, and if we know that one of our magnetic poles is slightly leaning over in an angle which is going to expose one of these cusps more directly to the solar wind, then more solar wind is going to come in through one of these vulnerable regions on our magnetosphere, and it's going to have a seasonal effect, because obviously we spend a lot of the nearly 3 months of the period of which we rotate around the sun at winter, 3 months in the summer. So the angle of that cusp is going to change as well with relationship to the modified position of the magnetosphere in relationship to where we orbit the sun on its plane. So we've got a lot more investigation to do. We've got to figure out how we can monitor the levels of radiation in the cusp regions. That would probably involve putting a magnetometer somewhere in Canada and maybe one in Russia, and we've really struggled to get magnetometers into Russia, but the only way we can monitor the levels of radiation probably would be actually not just magnetometers but also muon detectors, and we could get an idea during the next 12 months as we orbit the sun, the levels of increase and decrease with regards to muons here on the surface of the Earth. So guys, this is probably one of the most comprehensive explanations I've given on the magnetic pole to date, and the only reason why that is because now we've got more data than what we ever have done on the magnetic pole and its migration. This is only been able to be achieved by the support of a few people, and we have really met a mammoth task in asking those questions, and it's only been really through perseverance and a lot of hard work here at the observatory and dedication that we've been able to get this far. And there is still a lot unknown about all these things that are going to take place in a very short space of time here on this planet. We are in the process of a magnetic reversal, and I've always said this, there's a lot more to just these anomalies that are over the northern and southern hemispheres of our planet. And what am I talking about? I'm not just talking about the fact that we've got magnetic poles over these regions. We've also got Arctic conditions. We've also got rotational axes in the same place, and I've said this before, I don't think it's coincidence that all three are in the positions of which they are. And now we are pulling into this theory, the theory of a altered position of the magnetosphere, where the vulnerabilities of that magnetosphere wreak more problems on our weather patterns and our jet streams in more particular. So it is down to just those few people that have been constantly supporting us. We've reached a milestone here, guys. I hope you appreciate the work that's gone into this to date. And the unique thing about it is it's been open for the public, and not just the public that can afford now and then to chip in a few bucks, but for everybody. We've managed to keep it that way. And even at this point in time, it'd be so easy for me just to share with the patrons and the people that support us on PayPal the information, but we want to continue expressing the importance of this and trying to encourage more people to become supporters of this, because that's the only way we're going to be able to get more information to you guys out there. And that's really what this is all about. So there's a link down there, guys. Hopefully you'll understand to date now, with the knowledge that you've been blessed to receive in this video, hopefully making things a lot more clearer for you, the importance of the work. And with that, I want to wish you an amazing day, and just say, look, there is a link down there, and you can either use the PayPal link, or you can become one of our patrons. But the main thing is that it continues to get supported, even at a time where we're faced with the pandemic that we are, which I'm not going to talk about, but there you go. Have an amazing day, and I'll catch up with you at some point in the week, hopefully with some more interesting information on the topic to hand. Bye for now.